Okay, so I'll go ahead and get started. I'll kind of just recap what we did last meeting and what we'll go through this meeting. So last time we talked through the Python 2 to Python 3 set. I got that merged in yesterday. One thing I did say I would do is once that's merged, I'll create some issues surrounding actually accomplishing those tasks. Haven't gotten to that since we just merged it in yesterday. So I'll follow up so that's done before next meeting so we can discuss on whoever wants to possibly help with that and how we're going to attack that. And then the other thing that we discussed was Tom is working on a proof of concept to demonstrate bringing Salt SSH outside of the Salt repo. So yeah, I think for this meeting, does anybody have any comments on the Python 2 to Python 3 step? Okay, great. So it'll probably be a shorter meeting because we'll just ask Tom to tell us where he's at on the POC.
All right. I'll take advantage of the time given me.
Okay.
So yeah, in the last working group, some ideas were brought up relative to pulling Salt SSH out of Salt, potentially renaming and rebranding it, and trying to take the assets that we have and move forward there. So I started with one idea and threw it away, and another idea and threw it away. You know, the usual stuff. And right now I'm leaning towards a specific idea, and I'd like some feedback on it. But since we've got a small battery of time, unless there's a heavy objection, I'll just open up some code and we'll dive into kind of the idea that I'm following thus far and talk a little bit about POC. Okay. That means I need to now go like that and then share my screen and talk to myself and make me not sound credible in doing so. Okay. That looks fairly readable to me. And yes, world, I use kdevelop. I'm weird. Now, the project that I'm looking at here, the idea that I settled on was that instead of trying to replicate the behavior of Salt SSH, that would take a fundamentally separate approach. So some of the problems we run into with Salt SSH, apart from it being terribly slow, which is kind of to be expected given using SSH. But also it becomes very difficult to replicate the full functionality of Salt itself. So for instance, we don't get beacons. The mine and the peer systems are cold molasses slow. I'm trying to think if there's a German equivalent to the southern term cold as molasses. I don't know. Yeah, Pablo, is there a term for something really slow in German that's witty?
I actually don't know because I'm from Spain, so no idea of German as well.
Okay, Spain. Sorry. I should have remembered that. Okay. Anyway, my thinking shifted that since initial connection and startup time in Salt SSH is already not exactly zippy, and the systems which we're competing with aren't exactly zippy, I thought that it would make sense to, again, take a fundamentally different approach. And so let me run this by everybody here and just kind of ask for some feedback. I'm definitely not completely bought off on this approach yet, but by any means, this is still very exploratory. But the basic idea is that instead of running Salt SSH commands against a remote system, we would instead send a minion down there, similar to how we do it now, probably refine that process a little bit. But instead of executing salt call and outputting to JSON and reserializing that over the SSH median, we would instead create an SSH tunnel. Go ahead and start a master so that you would have an ephemeral master, or allow us to connect to an existing master, and then create a tunnel from some localhost ports on the target system over the SSH connection back directly up to the master. The idea there then being that we would still be able to maintain the SSH connection and have complete control over the running of the minion, which would allow it to exist for a short time or a longer period, allow us to use that connection as a system to automatically update and refresh those and maintain a separate connection for restarting said minions, allow us also therefore to have those minions be fully attached to the event bus, and logically it should run, you know, at a fairly similar clip to Salt itself, and all just via tunneling. And then my other thinking along these lines is that, well, if I'm going to make a system that is fundamentally made to distribute software and then facilitate tunnels, then why don't I do what we always do and make it crazy pluggable, so that we can, so that we would be able to automate arbitrary types of systems. And so that's just the current machination in my brain. Does anybody have any way to poke any holes in that on my behalf?
So you're just changing the transport layer, essentially, right? Or is there more to it?
No, we're not even changing the transport layer.
Okay.
We'd be legitimately just starting a minion, changing its config to think that the master's on localhost ports. And then we tunnel those localhost ports on the remote system through the SSH connection up to the respective ports on the originating system. I haven't gotten it to work yet. Again, this is just an idea. But yeah, and I wanted to run it by the group here and ask if there were any fundamental holes that anybody saw.
I just want to add something, because this sounds very similar to what we are already doing with SUSE Manager. So what we do here, that in some cases, the customer doesn't want to have all the minions connected through a master, but they want to have a proxy. They want to use a proxy. And have only that proxy connected to our master. So what we are doing, we have, I think it's a 0MQ, I don't know, kind of relay node, which we use as a proxy. And then the minion, this is in the local network of the minions. And all the minions are connected to the ports opened on this node, on the proxy node, and then all the communication is forwarded to our Salt master, which can be in another network. And I'm not sure if we already use Salt SSH to create a tunnel from the master to the proxy, but I don't see a problem in doing it in that way. Pablo, do you know if we already use a SSH tunnel for that?
Yeah, what we use, so this mechanism you are mentioning is a Salt broker, which basically forwards traffic from all minions behind or in some sub-network or in some network into this broker that basically is the one that then contacts to the master and passes all the events in both ways. But the idea of the SSH, I see, well, what Tom is mentioning, which I think is a really good idea, is for example, in cases where we don't actually have access from, let's say, the minions through the master in that direction, but just from the master through the minion. And creating an SSH tunnel from the master to the minion or to a broker or whatever and then just forwarding and do the pipeline, the pipes on the port. That's a really good idea. We actually use that for basically serving the channels that we have in SUSE Manager when we are in those situations where the minions have not access directly to the master, but the minions need to access those repositories which are in the master. So we basically create an SSH tunnel from the master to the minion, opening some local host port in the minion to serve then the HTTP. And so the repositories that are then configured on the minions are localhost and some port. And then all that traffic that is generated from the minion to that localhost port is going to be through this tunneling until it reaches the master. And that allows us to basically, well, in this case, it will be the idea of TON, I think, is basically the same, but with the 0NQ traffic. So we created from the master an SSH connection to the minion that maps those 0NQ ports in a way that then the minion is able to run and connect to a master which is in localhost and this particular port. And then all the traffic is going, and we can even have an established connection there and have the full traffic there, which, I mean, I like the idea actually. Really nice.
No, that's fantastic, and I really appreciate the feedback. That I mean, the fact that you're able to use similar systems in the wild really encourages me. I mean, it's always nice to make sure I'm not overlooking something obvious or not obvious. So yeah, you guys are fantastic as always. Okay. So let me switch gears really quick. The system that I'm building right now, so far I'm calling it Hice. After Heisenberg, of course, or rather the Heisenberg uncertainty principle, because the whole idea is one where you're able to assume that you have access to systems, but you don't actually have an impact on those systems till you look at them, but on chain. Now, but to accomplish this, I'm using a system called POP, and so I thought I'd take a few minutes and give a quick overview of POP and get some feedback here. So if some of you haven't heard of POP before, POP stands for Plugin Oriented Programming, and it is an evolution of the Salt loader. So if we come back and we look at the Salt loader, having that really flexible plugin system is one of the really big advantages to Salt in general. And so a few years ago, I started to I thought, well, it'd be fun. What would it look like if I made a standalone plugin system? And I iterated on the idea many times. I wrote it down somewhere, how many times. But ended up with really a fundamentally different approach to creating pluggable software. And I've really grown to like this approach. And so POP is released under an Apache license. It's currently version 6.0.0. There's definitely a lot more that can be added to it. It's a pretty slick project. And I'm wanting to, for a lot of the new open source pieces of software that we're pushing out, to base them on POP and this whole plugin oriented model. And so one of the main pieces of software that we have out right now that's based on POP is Umbra, which is an artificial intelligence pipelining system. And so let me go over POP really quick, and then I can dive into what Hice looks like right now. From a prototype perspective, I haven't released it yet just because I wasn't quite sure if I was ready to, to make and throw away something 18 times on, in the open. But anyway, if we go to POP, it's got a great little quick start here in my attempt to make this as easy to learn as is humanly possible. And so one of the main ideas behind POP is that you can make an application which is comprised 100% entirely out of plugins. so that if it's properly organized, you don't run into the problem of, well, I should make this system pluggable. The idea there also being that it's quite typical when we make larger systems and larger pieces of software that we end up needing to make them pluggable or modular. So why not just start with a paradigm that does it for you? And so the only code in POP that doesn't need to be in plugins is bootstrapping that system, okay? And so to bootstrap the POP system, all you've got to do is create an object that we call a hub, and you'll see a lot of the hub, and then add our first plugin subsystem. And in this case, we're making a plugin subsystem called poppy.poppy. And so when we pass in poppy.poppy, we're just telling it the py path to look up that plugin subsystem. So if we were to import poppy.poppy and then find out what directory path was returned from importing poppy.poppy, then we know the directory to scan for plugins. And that's the only code that doesn't need to be pluggable. And it's small enough and trivial enough that I think I can argue that this allows for a 100% pluggable piece of software, even though mathematicians may argue. Now, the next thing we do is we make this poppy.poppy directory, and then we create an init.py file. Now, inside of POP, having this init.py gives you an entry point into the subsystem. So we can kind of think about this plugin subsystem like a really big class, or like a big pluggable class. Okay. And then if you create it under a init function inside of the init.py, it gets automatically called when this plugin subsystem gets loaded. And then you've bootstrapped having a pluggable system. POP then seeks to solve some of the core problems that you run into with just making command line software in general. One thing that's always annoyed me a great deal with making command line software is that you have to solve the configuration loading problem. And so POP does come with a config loading system. This config loading system also allows you to do some pretty tricky things, particularly something that I call app merging. Inside of POP, you've also got the ability to take plugin subsystems for multiple applications and merge them together into one ecosystem. And if you're doing that, then obviously you also need to be able to merge configuration data from multiple subsystems. And so if you need to merge configuration data from multiple pluggable subsystems, then that configuration data needs to be dynamically loadable. And so then you need to be able to arbitrarily merge configuration data from multiple arbitrary projects into a single hierarchy, while also following all of the rules of configuration loading, which are basically that your command line options override your environment options, which override your config file options, which override your defaults. But then you need to be able to define your defaults in the command line options so that they're available in the, et cetera, et cetera. Many of you have gone through this lovely little conundrum before. And yeah, be able to like load config files and that whole little disaster. So POP comes with a system called conf that does all those things for you. And all you've got to do is fill out a dictionary with options that map either to POP's configuration system or back to good old argparse in Python, because obviously that gets used under the hood. Okay, so again, it makes it very easy to create a file called conf.py inside of your project that contains all of your configuration information. All right. Now, all we've got to do is then call the configuration loading system on our hub. And so when we make a hub, this is one of the things that, for the people in this room who are familiar with Salt, hopefully this will be easy to convey, or I'll convey it from a Salt perspective. Inside of Salt, when we have execution, when we have plugins, inside of those plugins, what we often need to do is inject dunder variables, right? The magical dunder salt and dunder opts and dunder context grains, et cetera, et cetera, et cetera, that get injected into the module layer. Now, how the Salt loader works is that it injects these directly into the instance of the module that has been created, which has a number of problems. I mean, I could talk about those for about I don't know, 2 or 3 hours. And so the difference with POP is that we always want to keep the module layer clean. And so you may have noticed that the hub is passed automatically as the first argument to this dunder init function, kind of like self in a Python class. And so now every time you call one of these functions, it automatically passes the hub as the first argument. And then the plugin subsystems exist on the hub, which means that we don't have to do any of this module injection. It also means that the plugin subsystems are more readily available in a broader context, and it makes it significantly easier to share plugins across multiple plugin subsystems, which is a constant headache inside of Salt, because we have to re-inject all of these function objects into multiple aspects of the application. And so now we just have a hub. And so hub.tools is similar to if tools was dunder tools that had been injected just like dunder salt. And so logically, if you wanted to cross-call another Salt loader function via a hub-style interface, it would be hub.salt.test.ping, okay? All right, but so that means that we also, and I've got a number of, you know, computer science programming arguments around encapsulation and object-oriented programming and blah, 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 blah. It's all in these docs if you know, you can't sleep one night. Now, once we call conf.integrate, we tell it the project that we want it to look for that conf.py file in, or a list of projects, so that we can do that app merging thing. And then on the hub, we get something called opt, which is a dictionary that links to the project that we loaded, and then the variables that are loaded from that project's config. And then, of course, you shouldn't change what's in opt. I probably need to write that in big bold letters in many places. Okay, otherwise, well, and it'll still be done. Now, I should probably go and make it frozen or whatever. Okay, anyway. So config loading is easy in POP. And then we can add more plugin subsystems. When we add a plugin subsystem, all we've got to do is give it that Python path again, and then we're able to just create that directory path. And then all of those plugins become available on the hub. And so in this case, we add another plugin system called RPC. It is now magically available on, sorry, I shouldn't say magic. It is now clearly available on the hub under hub.rpc, so that we can call those functions. And then in hub.rpc over here, I'm starting up an Async IO loop in this little contrived RPC server example that allows you to map these functions back into executing them directly on the hub, et cetera, et cetera. So that's a really quick overview of POP. There's a mountain of features and slick little things in there, but I kind of need to cover that before I start talking about a project that's built on POP, because in looking at that project, it might seem rather odd. All right. Any questions, comments, arguments, rebuttals? I feel like I'm more open to that this time than usual, since I just introduced a programming paradigm. I'm crazy.
It's the first time to me to hear about this POP stuff, and it sounds good, right? Mm-hmm.
Okay. Yeah, I mean, in a nutshell, the goal is to take what's really cool about the Salt loader and make it more generally available. and make things a lot cleaner and faster. And again, there's cool stuff in here. So POP also supports contracts. POP supports dynamic multi-library loading. So you can do app merging across multiple apps horizontally, but you can also do it vertically by saying that I've got say you've got a plugin subsystem called Grains, and then you can configure POP in such a way that you would be able to add a completely separate piece of Python install into your Python path that implements more grains. And if you set up your subsystem to do so, it will dynamically add those grains to your system as well. So that the end result is pretty slick, right? So that it becomes really easy to break up all these different modules to support different operating systems, et cetera, or different anything, really, making it really easy to vertically extend software. Okay. But so concept conveyed, and I mean, it's only been out for like a month. I haven't had time since I published POP and got a lot of these docs up. I mean, honestly, like 2 weeks ago. I haven't had a whole lot of time to set up presentations or anything. So welcome to, this might actually be the first time that I've gone through the introduction of the project outside of a few people inside of the company.
Nice.
Okay, so that means that now I am trying to share a different screen. Okay, going back to my IDE to talk about Hice. Now that you've all been versed in the wiles of POP. So, this run.py is just a nice little convenience script to run the whole sucker from the local directory. Of course, using a setup.py, you use setup tools, and then over here in scripts is where we've got our startup for the setup tools install, yada, yada, yada. But for the purposes of going over the application from start to finish, hopefully this makes a little sense. Okay, so we import the hub, we make the hub, we add Hice to the hub. Great. Adding Hice to the hub goes over here and calls this dunder init function inside of the Hice plugin subsystem. So one of the other things I should mention is that POP comes with a little tool called POP seed that you can run from the command line that auto-generates a setup.py that automatically loads all the POP stuff and auto-generates your configuration file and all of the things for you. The tutorial obviously doesn't use that because it's better to know than to be helped. I mean, a lot of people argue with me on that from a philosophical perspective, but whatever, I'll stick to my guns. Okay. And so what we're doing here is first we load up the configuration, and so let me open up that configuration here. The configuration has a number of options, and hopefully by just looking at this, hopefully it's kind of obvious how that's laid out, right? You can define help, you can define what the default value for those options is, and you're good to go. So all of those options with this marvelous little one-liner here on hub.tools.conf.integrate gets loaded. All right. Then we load some additional subsystems, plugin subsystems down here. You might notice that I'm using the dyne name option, which allows us to use that dynamic vertical app merging thingy. There's totally a bug in it right now, for the record. Welcome, yeah, welcome to life. So that's where I was last night, is fixing that bug. Okay.
I got a quick question.
Yeah.
While you're running through this. So the way that those are laid out, is it correct to assume that because it's using that application merge, that if something happens to be in one of it, so I'm assuming it does roster first, and then if there's something in tunnel that overrides roster, then it overrides what's in roster? Or?
No.
No, okay.
No, so when we're giving these a name, we're giving them the name that they're going to operate on inside of the hub. And so as I load up roster here, that means that roster is now added to the hub down here.
Okay.
And so tunnel is added to the hub.
Okay, so
targets added to the hub.
They're created as separate things within that.
Now what it does, so to cover the app merging real quick here, is if we go back to conf.py, there's an option you can put in here called dyn, which allows you to map out your dynamic includes. And so this dyn statement is just saying that if anybody uses the dynamic name Hice, then this project is, can you close the door, please? If somebody uses the if someone uses the dynamic name Hice, then it's going to automatically detect, and so this is someone in a separate project. It's going to dynamically detect that this project implements Hice plugins. And then those get merged together, similar to how external mods works in Salt.
So this would be like if someone in an external project, external system reference Hice, you can have whatever Hice depends on or
whatever the Python, or sorry, whatever the plugin contract that's expressed in there, it just gets the namespace becomes extended. So from a Hice perspective, this dynamic naming makes sense because tunnel is the plugin system where we implement creating SSH tunnels. Let's say that somebody wanted to make their own project that created tunnels over, I don't know, some other tunneling piece of software.
RSH.
Yeah, RSH. Someone is foolish and crazy. Then they would be able to create a project that implements dyn tunnel. And then when they started up Hice, because it's loading the tunnel as a dynamic name, then it will automatically detect this other project and it can add it to the hub. Okay? And so another example of this would be, like I was saying before, but let me use a different paradigm. So let's say that Salt was using this. We'd be able to install an additional Python package that had all of its SUSE support created in isolation in this specific little package for all of the zipper, et cetera, et cetera. Somebody else would be able to maintain that completely, test it completely in isolation, and then it would only have to be installed on SUSE systems, and then it would implement the dynamic names for grains, modules, et cetera, et cetera. Okay? Does that make sense?
Mm-hmm,
okay.
Mm-hmm. Yep.
So, I mean, that's the idea there. Okay. So, yeah, and last night I found out that in my current implementation, if I use multiple dynamic names on the same hub, then I'm running into a recursive loading issue. So yeah, I gotta fix that. Welcome to, I made this feature last week and apparently needed to test an additional case. So I'll have that fixed. Anyway, we load these up and then we fire up an Async IO loop. Now, Hub provides an interface for an Async IO loop that I'm using here that just kind of makes that easy. Now, there are a number of little hurdles when you start getting deeper into Async IO. I don't know if anyone here has done a lot with Async IO, but one of the annoyances of Async IO is that if you create a future and never await that future, then you never give the interpreter the opportunity to retrieve any tracebacks which occurred inside of the execution of said future. Which means that if you create a future, which there are certainly situations where I think it makes sense to want to create a future to just be executed passively at a later time, or allow a future to kick off continually. So there's a number of little problems like that that are solved inside of POP's Async IO tools. So for instance, you can use POP's Async IO tools to create a future, and then POP adds that future to a queue located on the hub, and then watches that Async IO queue and automatically awaits the futures when they complete, to oversimplify it. But so I start the loop here using some loop tools inside of POP. One of the other things that's great about having the hub around is that the hub creates a hierarchical namespace. And so normally when we think about object-oriented programming, one of the most important aspects of object-oriented programming, of course, is encapsulation. The concept is quite simply that you have a class, and therefore you have data, which is relative to your functions, and the data and functions are encapsulated inside of said class. But one of the challenges that we run into when we start writing software that has many classes and instances of classes is that it's fairly common that we've got a piece of data hanging out in some instance of a class somewhere, and we can really use it someplace else, right? So the hub concept differs in that we say, instead of having a bunch of objects ethereally floating on the heap, right? Whenever you create an object or instantiate something, its data should be inside of a relative namespace on the hub. That means that the data is globally available, which gives you the benefits of globals, but it doesn't give you the problem of globals, of saying that you now have globally logically writable and hard to track variables. The idea there being that if I'm inside of the roster's plugin subsystem, I can put a variable directly on hub.roster, and by doing so, I have communicated that, sure, anybody can read this variable, because, I mean, we're in a process. I can't isolate reading variables from a security perspective, so why bother? But then we are issuing the convention that only plugins inside of the roster plugin subsystem should be writing to that variable, so that we're able to communicate the nature of the variable in which we have from a private protected public perspective, and that we can do so across a hierarchical namespace. That means that that information is always publicly available. This can make async IO programming way the heck easier, because all of a sudden we can have lots of coroutines all over the place that just naturally go back to the same location on the hub as their coroutine communication interface. This is something that I use a lot inside of Umbra, for instance, to implement a flow programming style approach, where we've got data that comes in, goes into an async queue, and then we've got other functions that are awaiting for data to be received in that queue. Okay, so anyway, POP can help you write async code. All right. And so then we come in and we go into the roster system. We initialize the roster system. We take whichever roster we have chosen to be configured as the roster that we want to use, pass that into roster init, which then takes that information and generates all of the target information that we need for, again, targeting and creating SSH connections to multiple systems. And so if we go into the roster system, pretty cut and dry, where we just say we're going to get an attribute on the hub. The hub has implemented nested get attributes, so you can say get attr hub, and then give it a dot delimited string path. Which makes it really easy to be able to say something like, I've got an arbitrary plugin function and or module that I want to execute or get access to, or variable, etc. And so I can just run a get attr on the hub directly. Okay? And so in this case, what we're doing, just to, again, go over this from a POC perspective, is that we call the read function on roster.init. As you can see, this init does not have a dunder init function because it doesn't need one. It doesn't need an initializer. And so then we call read. We pass in which roster we want, the target and the target type, terms everyone in this room is familiar with. And then we retrieve the function from the respective roster that we want relative to the hub. And then we run that function and pull the information out of it and prepare that dictionary for use. And so whammo, we've got targets. Next, Hice has a concept of a manager. And so that manager is actually what the Hice plugin subsystem implements. And so in this case, we've then got a Salt master. And so then this manager allows us to have a plugin that says, this is what it looks like to deploy to the target that we have a plausible connection to, and deploy to that target the functionality around tunneling salt. But this also means, again, since we're making everything a plugin, that if I wanted to tunnel any other network protocol through Hice's existing connection systems, then that becomes instantly available through the implementation of one small Python file, okay? And since it's dynamically loaded, that one small Python file can be its own independent project, doesn't need to be merged back in and maintained with the mainline project. So for instance, we could logically do something like allow for chef or puppet routines to be tunneled directly through this same system and subsequently create ephemeral agents for those, or for anything else. I mean, we could use it to create ephemeral agents for security scanners, or I mean, just whatever, right? Okay. Which is really where it comes into is the mindset of creating software that fundamentally branches out to multiple integration points. Instead of what we generally do, which is write a piece of software that executes a single function and then rewrite it or shoehorn it violently into being able to accept integrations, okay? All right, and then the tunnel system, similarly, is also a plugin system. And you can put a dunder init on individual plugins as well. So this is a plugin on init.py, which means that when this plugin gets realized, it'll execute its dunder init. And in this case, as you can see, the execution of the dunder init of this plugin system puts a variable on the hub that can then be used inside the plugin system. And then in here, we've got some functions which implement a contracted interface, which gives us the functions that we need to create and maintain a tunnel. Okay? Anyway, that's where I'm at there. Sorry if the ending is anticlimactic because it doesn't work yet. I don't have as much free time as I used to. Now, but yeah, it sounds like the general consensus is that aspects of this idea are probably good, and I'm planning on plowing ahead with this. From a large scale Salt SSH planning perspective, we're going to keep seeing if this other Hice idea can be made viable. If it can be made viable and we can prove it out to work and we make it so it can work with existing Salt SSH rosters, then we'll probably circle back around at that time and decide whether or not we want to look at deprecating Salt SSH in favor of Hice or an amalgamation thereof. Okay, so any questions, comments, arguments, or rebuttals?
No, I mean, this seems a very complex system, so that then I don't have any smart opinion right now because it's a bit hard to digest, like from the It's my first time looking at this, and then. But it seems like you've given a lot of thought here, and looks pretty good. I mean, it has very good ideas, and it does things in a better way than we have things in Salt right now. So it would be great if this would work, and then we could migrate. I don't know what's the plan. Maybe you want to migrate Salt SSH first to this system, but then I don't know. Maybe even the normal Salt could benefit from this. I guess you are thinking to make like an experiment with Salt SSH, see how that works, and then plan from there.
Oh, yeah, and definitely. I mean, it sounds like you're catching the gist that a lot of the concepts I've tried to put inside a POP are concepts that would be able to absorb a significant amount of Salt zone functionality. And so I played around with the idea a lot of compartmentalizing Salt through POP, right? Coming in and doing things like saying, let's take the execution module system in Salt and popperize it. Let's take grains and popperize it. I mean, like POP solves all those fundamental problems that we run into with generating grains anyway and having a huge cord up in grains, which is bad. But the more I look at it, the more it turns into like this intricate web, right? Because I say, well, I think it'd be really slick to popperize grains first, and I start looking into popperizing grains, and all of a sudden I'm looking at it saying, goodness, this means I'm going to have to popperize 18 other systems. The thing about Salt SSH is that it can be cleanly created on a POP system and still inherit a lot of the code and functionality that we have inside of Salt SSH. It only requires that we popperize 3 interfaces that are inside of Salt, and that's rosters, targets, and renderers, because in Salt SSH, target files are processed through renderers. And so, I mean, and I keep running into this, that I need renderers for like everything I look at. They're really nice to have. But yeah, I mean, similarly, as an experiment, I went through and I popperized a couple of components inside of Salt. So for instance, I made a completely pluggable implementation of the Salt state system. I don't think I've released that one. I don't think I released item, probably because I made it and I haven't touched it in like 5 months. But it's slick because it makes the creation of new requisites a plugin. And so you can make new requisite just by defining a plugin with 4 lines of code, and then you have a new requisite. It's pretty cool. But yeah, I mean, yeah, as you're driving towards, I do view Salt SSH as an initial experiment to see if the POP paradigm is something that will work to be able to pull these things out, and also to see if there are major pitfalls, and that it's an isolated area that I can try this out with, without damaging any existing projects. Because, you know, if we get to the point where we say, look, it's clear that Tom was just up in the night with this whole concept, which is totally plausible. I mean, don't get me wrong. I mean, I think it's good, but, you know, time tells. Then we still have Salt SSH, right? And we still have a plan moving forward for the maintenance and care of Salt SSH. If it proves that we make this system out and we go, hey, this is really slick, then we can decide at that time if we want to follow things like deprecation paths. Does that answer your question?
Yeah, that's great. It sounds pretty good. I'm looking forward to see more of this. I have one more question, or maybe, I don't know, suggestion, or maybe you already thought of that. I was thinking, you said that let's take the tunnel module or plugin, and let's say there are two implementations. How one can be sure, or at least test that the I don't know, the API or the functionality of one of the implementation compares to the other implementation? Or how do you think of comparing that, or to make sure that both offer the same functionality so that we don't have critical crashes when we use one implementation or the other?
You're right to ask this, because this is one of the fundamental things missing in Salt's plugin system, and this is actually the first thing that I added to my early iterations on POP. So POP comes with a construct called contracts, and inside of contracts you can define what needs to be implemented, how it needs to be implemented, etc., for all plugins, so that that contract layer allows you to fully validate and vet a plugin before it's ever accepted onto the hub.
Okay, that sounds great.
Yeah, because that's the thing. that is like the main thing I overlooked when I wrote the Salt loader. And by overlooked, I mean couldn't have possibly imagined needing it to be a thing at the time, because at the time I didn't think it was going where it was going. You know what I mean?
Yeah, sure, of course.
Writing software.
Yeah.
Okay, but no, you're exactly right. Did you have another question, or is that it?
No, that was it. Yeah, I didn't. Maybe I didn't understand what you mean by contract, but now it's clearer. Thanks for answering.
Okay, and actually, I don't think contracts are documented right now, because I rewrote the entire documentation. They're like mentioned.
Sorry, what?
There's a bunch of things I still need to add to contracts. Right now, contracts have a few really light interfaces, but I want to be able to add much more aggressive checks around them. But one of the great things about POP is that all of the functions that you see on the hub are actually these contracted objects. And so you can call the contracted object, and then it calls that underlying function. But since it goes to the contracted object, it gives us, unlike the Salt loader, it gives us a layer in which we always have the option to inject more checks. And contracts are also invoked at the time when we create a subsystem, as well as when we load modules, so that we can have checks and validation at multiple layers in the system. So that we can solve all the different machinations of those problem sets that we look at.
Is this a contracting module also a plugin, or is it built in?
Yes.
Okay.
Everything's plugins. I mean, it's an unhealthy amount of plugins.
Do you think that, I don't know, I was just thinking, would this thing be able to be split in, I don't know, microservices? I was just thinking that maybe one module would not even be Python, but something else, but then still be able to work with this, I don't know, platform, I don't know how to call it.
I definitely think so. And there'd be a lot of different ways that we could consider how that could work. One of the things about, one of the jokes, I don't know if it's a joke or not, but we I kind of refer to the fact that app merging inside of POP allows you to create kind of this nano service construct, where you can have a single process that is able to facilitate lots of services in itself, which helps solve some of the problems that we have with just general breaking apart of large applications. But nano services would also make a lot of sense to be able to have some of those basic interfaces that we're exposing from a pluggable perspective to be able to use the hub to dynamically communicate across a microservice infrastructure as well. In making this, I've also been thinking a lot about function as a service paradigms. Because a function as a service paradigm, one of the problems, of course, that you run into with the function as a service paradigm is that you get function sprawl all over the place. And a lot of my thinking around POP is to be able to say that if we're creating all of these functions, we could be creating them inside of a plugin infrastructure. And that a plugin infrastructure for a function as a service paradigm would make it significantly easier to create and deploy more unified code bases that are easier for humans to manage, but then have those code bases still be dynamically distributed across a fast infrastructure. So yeah, like as far as I'm concerned, you are pushing all the right flipping buttons.
Okay. Okay, it sounds pretty good. Thanks for showing this to us. Like, maybe, I don't know if it's the first time, but it's in a maybe in early stage, so thanks for that.
Yeah, thanks for being patient and listening through an SSH working group where I explain an entire logical stack to accomplish strange things.
Yeah, it really sounds good, Tom. Yeah, good job.
Okay. All right, we're out of time. Does anybody have any other questions or comments? Okay. Until next time, hopefully from a Salt SSH perspective, we've got a few more things to go over next time as well. My goal will be that I've got a working prototype of Hice next time. And from a Salt SSH perspective, we've got a number of issues to open and get assigned. So, yep, moving forward.
Great,
Okay.
sounds good.
All right, until next time. Thanks, everyone.
Yeah. Thank you. See you.
Thank you. Enjoy. Ciao.
See ya.
Bye.